Hi girls and guys. In this module Jack and Jill are going to move a counter around our game board a set number of squares, with a code loop, in timer 1, according to the value we got when we rolled the dice earlier, in a previous module. In this case our dice score was 9, which was stored in the integer variable called id0. Our game is for 2 players, Jack and Jill. Each has a counter on the board. In the code that we write, we need to keep track of whose turn it is. We store this in the integer variable called iturn, which equals 0 for the first player, and 1 for the second. When the player's counter has been moved, and is not on the home square, we increment the value stored in iturn, with the code, iturn plus equals 1. But we only have 2 players, so we have to tell the computer that if iturn equals 2 then iturn equals 0. Otherwise it is no one's turn anymore. We have to move the correct counter after the dice has been rolled, so we use the integer variable iCounter followed by iturn in brackets to identify the right counter. We need to know the location of the counter, using the coordinates, ACR and DWN and its direction of travel, which we store in the integer variable iDirection, which can have a value between 0, and the total number of changes of direction on the board. The games that were suggested are Ludo, and Snakes and Ladders, which is difficult enough with all the snakes getting in the way. But both games have 3 levels of difficulty, 0 to 2, which the player chooses at the start of the game by clicking the relevant button. We store this in another integer called iLevel, which has nothing to do with cooking toast. But we go into levels of difficulty in greater detail in another module. We move the counter using timer 1. We tell the computer what place in the timer code to go to in the integer iTick, which we get from checking the value of iDirection with a select case, case is equals, end select, routine, which is covered in another module. We will assume that it is player 1's turn and this is their first throw of the dice. Therefore iturn equals 0. ACR iturn and DWN iturn equal the coordinates of the start square. We were clever enough when we drew our game's background picture, to make each square exactly 80 pixels by 80 pixels. This makes it very simple to move the player's counter around the board. By incrementing ACR iturn if traveling across the board, or DWN iturn if traveling up or down. We also have to decide what to do when a counter lands on top of the opponent's counter, because each object in a computer program has a level order that hides from view any object with a lower level if they both occupy the same space on the screen. In level 3, we do not have this problem as the opponent's counter is gazumped, and has to return to the start square. We also have to detect when a counter has to change direction on the board. So we need to know the coordinates ACR and DWN of these squares, which are checked by the code blocks in timer 1. We cover all this in another module, because we want to keep things as simple as possible at the moment. Both games need to detect when a counter reaches the home square, by checking if our counter's coordinates are equal to the home squares. If they are equal, then the winner is declared and the game reset to start from the beginning again. The code for this is: if ACR iturn equals ARC home square and DWN iturn equals DWN home square, then go to game over, else iturn plus equals 1. We tell the players whose turn it is by putting text into a label on the screen. Label 1 text equals: player 1's turn is over. It is now player 2's turn to click the roll the dice button. Rolling the dice is covered in the random number module.